Hello everyone, welcome back to my channel. If you are new here, my name is Hasan and I am a class 12 student from Bangladesh. On this channel, I share my journey, including not only my life experiences but also the skills I am learning along the way. Today, I'm very excited to share something different, my Python project. You may be wondering why, as a 12th grade student, I'm sharing a programming project related to computer science. Actually, I'm quite interested in programming. That is why I began learning it on my own, in addition to my academic studies. After learning a few Python topics, I created my own project. The project I created is a mathematical problem in physics about an isolated spherical capacitor that I encountered during my academic studies. At the time, I decided to apply my newly acquired programming skills to my academic studies. In this video, I will explain what the project does, how I built it, and what I learned along the way. My English might not be perfect yet, but every word I speak here is part of my practice, and your feedback will greatly help me improve. So, if you are interested in coding, personal development, or just watching someone build and learn in real time, stay tuned. And if you'd like to support me on this journey, please consider subscribing, leaving your thoughts in the comments, and sharing this video with others who love learning and creativity. So let's get started with my Python project. So here we are inside the Visual Studio Code, and you can see I've already opened my project file capacitance.py. Visual Studio Code is a widely used code editor for programming. As you can see, the program contains many lines of code. I'll walk you through each line step by step, explaining how the program works and the formulas behind it. So let's start with the first line. In the first line, I have instructed the program to take the radius of the isolated spherical capacitor as input from the user and store it in a variable named R. I have used the input function to take the input from the user. You can see there is a text. Enter the radius of the conducting sphere in meters inside the double quotes of the input function. The text is called a prompt, which will be displayed to the user in the console to indicate what kind of input is expected. Usually, the input function takes input as a string. That's why I have used the float function to convert the value into a floating point number. That's what the first line does in the program. In the second line, I have instructed the program to take the charge of the capacitor as input from the user and store it in a variable named Q. I have used the same functions that I used in the first line to take input from the user. These two lines are the input parts of the program. The calculation starts with the next line. In this line, I have created a variable and named it C. The value of the C variable will be the capacitance of the capacitor. To calculate the capacitance, I have used a formula of static electricity in physics. The formula is 4 pi epsilon naught R. That means 4 into 3.14 into 8.85 into 10 to the power minus 12 into R. Here, 3.14 is the value of pi and 8.85 into 10 to the power minus 12 is the value of epsilon naught, and R is the radius of the capacitor, which will be inputted by the user. That's how the capacitance will be calculated by the program in the third line, and it will be stored in the C variable. Now, it's time to calculate the voltage of the capacitor. In the next line, I have created another variable and named it V. The value of this variable will be the voltage of the capacitor. I have used a basic formula of static electricity to calculate the voltage. That is, voltage is equal to Q divided by C. Here, Q is the charge on the sphere which will be inputted by the user, and C is the capacitance of the capacitor that will be calculated by the program in the third line. Thus, the voltage will be calculated by the program in the fourth line. The working process of next three lines are same as the previous two lines. In the next line, I have taken one more variable named U, whose value will be the stored energy in the capacitor that will be calculated by the program using the formula stored energy U is equal to Q squared divided by 2C. Here, Q is the charge of the capacitor that will be inputted by the user, and C is the capacitance of the capacitor that will be calculated by the program in the third line. Now, let's go to the next line. In this line, I have taken one more variable named E, whose value will be the magnitude of electric field on the surface of the capacitor that will be calculated using the formula E is equal to 1 divided by 4 pi epsilon naught into Q divided by R squared. I have already told the values of the unknown variables of the equation. Next is the last line of the calculation part. This line calculates the energy density in the electric field of the capacitor and stores it in the variable den. The formula behind the calculation is energy density U prime is equal to half into epsilon naught into E squared. Here, the value of epsilon naught is 8.85 into 10 to the power minus 12, and E is the magnitude of electric field of the capacitor. From the next line, the output part of the program begins. In the next 5 lines, the program just prints the values of the properties of the capacitor that are calculated in the calculation part. I have used the print function to print the values. There are some text inside the double quotes of the print function that will be displayed to the user in the console to indicate what kind of output is given. And the last line is called a comment that is not a part of the program. The comment only indicates what the program does. Comments are used so that anyone who works with this program after me can understand what the program does. Now, let's run the program to see if the program really works. I will simply use the run button to run the program. As you can see, the program is asking to input the radius. Let's enter 6 centimeter. That means 0.06 meters. Now, it is asking for the charge of the capacitor. Let's enter 2 coulomb. You can see that the program has calculated the properties of the capacitor and printed it in the console. If you have any doubt about the calculation, you can check it using your calculator. If any calculation doesn't match with the program's calculation, you can let me know in the comment box. I will try to fix the problem. However, the program has a limitation. The limitation is that the user has to enter the inputs in only SI units. That concludes my Python project walkthrough. I hope this video demonstrated how even a simple project can teach us valuable lessons not only about coding but also about patience, practice, and consistent progress. If you found this helpful or inspiring, please subscribe to stay updated. I'll be sharing more projects, ideas, and lessons that relate to coding and life. Thank you for watching, and remember that every small step toward learning is a big step forward in the journey. See you in the next video.